Hello student, I am Miss Sonali Gotraj from Computer Department. In today's session, I am discuss about fundamental of data structure. We are discuss about following content. First is abstract data type. Second, example of abstract data type are stack, queue and list. Third, operation of abstract data type. And fourth, feature of abstract data type. So let's start the session. Abstract data types. The abstract data type is a special kind of data type. Those behavior is defined by a set of values and set of operation. The keyword abstract is used as we can use this data type. We can perform different operation, but how those operations are working, that is totally hide from the user. The abstract data type is made of with the primitive data types, but operation logic are hidden. The data type is basically a type of data that can be used in different computer program. It significant the type like integer, float, its. The specific like integer will take 4 byte, character will take 1 byte of a space its. Data type such as integer, float, double, long, its are considered to be inbuilt data types, and we can perform basic operations with them such as addition, subtraction, division and multiplication. Those operations can be defined only as and when we require them. So in order to specify the process of solving problem, we can create data structure along with their operation, and such data structure that are not inbuilt are known as abstract data type. Abstract data type is a type or class for an object whose behavior is defined by a set of value and set of operation. The definition of ADT only mention what operation are to be performed, but not how those operations will be implemented. It does not specify how data will be organized in memory and what algorithm will be used for implementing the operation. It is called abstract because it gives an implementation independent view. The process of providing only essential and hiding the details is known as abstraction. This is a diagram of ADT, that means the abstract data type. Memory indicate data structure. In data structure include array and linked list. Array and linked list access public function and private function. Application program is interface those function, that is public and private. Those functions are abstract data types. Data type does not need to know how the data type is implemented. For example, we have been used primitive value like integer, float, character data type only with knowledge that those data type can operate and be performed on without any idea of how they are implemented. So user only need to know how a data type can do, but not how it will be implemented. Example of ADT. First, list ADT, that means list abstract data type. Second, stack ADT, that means stack abstract data type. And third is queue ADT, that means queue abstract data type. We can show these all three examples step by step. Let's start. First is list ADT. The data is generally stored in a key sequence in a list which has head structure consisting of count, pointer and addressing of compare function needed to compare the data in a list. Second, the data node contains the pointer to a data structure and a self-referential pointer which point to the next node in the list. Second, Stack ADT. In a Stack ADT implementation, instead of data being stored in each node, the pointer to data is stored. Second, the program allocate memory for a data and address is passed to the Stack ADT. Third is queue ADT. The head node and the data node are encapsulated in the ADT. The calling function can only see the pointer to the stack. Second, the stack head structure is also contain a pointer to a top and count of number of entries currently in a stack. Let us see some operation and function of those mentioned ADT. First is list ADT operation. First operation is get. Return an element from the list at any given position. Second, insert. Insert an element at any position of the list. Third is remove. Remove the first occurrence of any element from a non-empty list. Fourth, remove add. Remove the element at a specific location from a non-empty list. Fifth, replace. Replace an element at any position by another element. 6. Size. Return the number of elements in the list. 7. Is empty. Return true if the list is empty, otherwise return false. 8. Is full. Return true if the list is full, otherwise return false. Second is stack ADT operation. First, push. Insert an element at the end of the stack called top. Second, pop. Remove and return the element at the top of the stack if it is not empty. Third, pick. Return the element at the top of the stack without removing it if the stack is not empty. Fourth, size. Return the number of elements in the stack. Fifth is empty. Return true if the stack is empty, otherwise return false. 6 is full. Return true if the stack is full, otherwise return false. Third operation, queue ADT operation. First, enqueue. Insert an element at the end of the queue. Second, dequeue. Remove and return the first element of the queue if the queue is not empty. Third, pick. Return the element of queue without removing it if the queue is not empty. Fourth, size. Return the number of elements in the queue. Fifth is empty. Return true if the queue is empty, otherwise return false. 6 is full. Return true if the queue is full, otherwise return false. Feature of ADT. First, abstraction. The user does not need to know the implementation of data structure. Second, better conceptualization. Abstract data type given as a better conceptualization of real world. Third, robust. The program is robust and has the ability to catch error. This function we can easily find out different type of errors in program.